So I'm Adam Levitas. I'll be doing the rest of the analysis. Just for Rob is on the camera. So for the actual analysis part of this structure, we're using a standard positive moment convention with our two moments facing clockwise on the left-hand side of the beam and counterclockwise on the right-hand side. The reasoning was for this is that the beam is fairly simple and symmetric, and there wasn't a need to complicate issues with an always clockwise positive moment sign convention. We still will be using the K equals I over L, given that the E times I is constant. And by inspection from the beam, there were no fixed end moments. There's only point loads acting directly upon the supports. So for our first cut between the end cantilever D and the support A, there's a 6 kip force acting 8 feet away and no intermediate supports. Therefore, MAD has to be acting in a clockwise sense with a total magnitude of 6 kips times 8 feet for negative 48 kip feet. Once again, using our normal sign convention. Now, between cuts 1 and 2, there's the moment from AD, which we calculated previously, and the moment from AB, which is what we're trying to find. The point load, again, acting directly above A, contributes no moment when taken about A, and therefore MAD has to equal MAB, resulting in an MAB of negative 48 kip feet. Moving to the other side of the beam, for cut 4, similar situation to cut 1, where we have a cantilever with 6 kips times 8 feet. You get our moment from CE to be negative 48 kip feet. And then similar to, again, to the other side by symmetry, cut 3 and 4, about the reaction at C, you have a moment at CB having to equal the moment at CE, resulting in negative 48 kip feet. So the only remaining moments that we have to find per the problem statement would be the moments BA and BC. And we can solve these by looking at the beam now as just being the 3 supports, no cantilevers, and instead having N moments applied of negative 48 kip feet, corresponding to moments CE and AD. Once again, the loads act directly above the supports, so they contribute no additional moment. From our analysis of using our Ks, we know that all the E's were the same, all the I's for the beam were the same. So your K between points B and A is going to equal your K between points B and C, which, if you cancel out the I's, is just going to be 1/2, as the 10s are all the same length between A, B, and B and C. So therefore, taking that distribution factor of 1/2 to our negative 48 kip feet from either side, it's going to result in your MBA equaling your MBC for 1/2 times negative 48, or negative 24 kip feet. So that solves all the moments that we had to find. Now coming over to our moment diagram, since we used a positive sign convention, we can just take the value of the moments as we determine them. And then going along between the 8, 10, 10, and 8 foot spans, we'll go from 0 kip feet at the end cantilever, for a moment at the end cantilever, down to negative 48 at the first support, up to negative 24 at support C, at support B, sorry, back down to negative 48, and then back up to 0 at your end cantilever.